Hey everybody, welcome back to another fantastic episode of Ready to Die Fighting. I'm Chris, and today we are going to be going back out to the final frontier, but not very far. We're going to stay in our little neck of the universe. And there's our sun, 93 million miles away. We'll find this beautiful blue and green planet, know it'll like it, in our little Goldilocks zone of our solar system. Us, Earth, home. And 240,000 miles away, our little buddy, the moon. And that is who we are talking about today. So like and subscribe if you want to learn about the moon and you like these videos. Throw me some comments and questions, corrections, whatever. Let's get into it. Phases of the moon is what I'm talking about. And just a little bit about the moon in general. Alright, so let's just do a little bit of shading here, because that's important. We're learning about night and day and the phases of the moon. The first thing I want to talk about with the moon is that it has a very important role on us, and it's very helpful to us. How is it helpful to us? What was I going to say? But the important role it plays is the tides. That's what I was going to say. The moon is responsible in part. The sun is also, to a lesser degree in part, responsible for our tides, the water levels going up and down on our shores. The moon is gradually moving away from us at the pace of like a fingernail. Eventually we will lose our moon. We'll all be long gone long before that happens, but it is something that's happening. It's gradually moving farther away from us. The moon rotates and revolves around us in the same way that we rotate and revolve around the sun. What's cool about it is we have something called tidal locking. So there's like that misnomer, I don't know if misnomer is the right phrase, but the idea of a dark side of the moon. And you know how we always kind of see those same couple of craters. The moon is always its face always looks the same to us. And so I think a lot of people think, or like the belief might have been, that this dark side of the moon never gets any light. It's always facing away from the sun. However, that's not true. It's always facing away from us, but the backside does get as much light as the front side does. It goes through night and day, just like, the Earth does, and, we just never see it. The moon and Earth are locked to each other, and I can show this pretty easily with the help of George Washington and this guy. I don't know who he is. And they've got faces and eyes, and so that's, I like to show it that way. And just to make sure you can see him, I'm going to give him some razor eyeballs there. And there. So now picture that this is the North Pole here, and we're looking down on the Earth on the top. And so as the moon rotates around us, this takes it about 30 days, 28 days actually, to make its full journey. The entire time it's rotating at a speed that matches, and so it is always facing us. And I just think that's so sweet. He's like always wanting to look at us. And we're just locked in. Like I said, it's called tidal locking. It's something that typically happens with moons and their planets. All right. The other thing that I wanted to talk about with the moon is, even though we always see the same face of it, it's always looking different. Sometimes it's a half C, a whole Z, quarters, little slivers, all that. And I find it fascinating. So let's talk about it. Let's start over here. In this position, let's set the mood here. I'm actually going to, let's do this. So this side is going to be darkness. Here's our nighttime. And I'm going to flip this guy over, and let's just make half of this black. And that's going to be darkness, where it's nighttime. There we go. And just for a little extra mood, Alexa, turn off the lights. Oops. There we go. All right.
Okay.
Thank you. Now we have like a perfect representation of the sun and the moon and Earth. So if we start right here, let's call this day 1 of the moon's journey around us. And let me make one more adjustment here. So let's call this side over here. I'm going to call that right, if we're right here, and left. I suppose that could be east and west, but that's easier for me to think of that way. So this is where we can see, where we're standing. If we're standing right there on Earth right now, this is to the right, that's to the left, and this is what we see. We see blackness. It's nighttime for us. As it spins over the course of a day, right now we've got dawn, like light is just starting to break here. This is going to be noon. Turning is, the sun's rays are hitting us at an angle, so we might be getting some pretty colors as they're bending around, and it's getting dark, and now we're back to midnight. So that's what that's going to look like, night and day for us here. So right now, this is our new moon. And if you see the dark side of the moon that faces, because it's always facing us, right? So this is the dark side. It's getting plenty of light. It's getting full daylight. It's noon for the moon. It's also, right here, noon for us. And that's what's kind of cool. When we're at the new moon, the moon is aligned with the sun, and it's just tracks it perfectly. It's like right there, dead center. So wherever the sun is as we're revolving, at new moon, it's right behind it. So at nighttime, we can't see it at all. We're over here. It's gone. And during the day, if we're looking, you ever play baseball or something and somebody's throwing a ball at you and you look up and it gets right in front of the sun, you can't see it at all. Like it just disappears and you just hope that it's not going to hit you in the face. Same thing. We can't see it during the day. It's overwhelmed by the sun's light. So we see absolutely nothing at the new moon. So, let's not put it there. Let's put it off to the side. Actually, maybe that was fine. I don't know. Whoops, that's red. I don't want red. New moon, right there. Nada. It's gone. So after a couple days, it starts moving, and this side is going to stay facing there. And now at nighttime, depending on the time of day, time of night, we might see a little bit. We see mostly darkness, but we might be able to see just a little sliver of light there. And so that is our crescent moon. Where did I put it? And so what we're going to see is something that looks roughly like that. And depending on where it is in this period, it may be bigger or smaller, if it's where it's at in its journey exactly. But we're going to see a crescent. And depending on the day, time of night, we might not see it at all. The moon rises and sets just like the sun. So depending on where we are, sometimes you can see the moon during the day, depending on its position, depending on the time. And by the time you get over here, it's already set. We can't see it anymore. Now, as we get over to this side here, this is what we call a quarter moon. And you're going to be seeing something like that. Probably think of it as a half moon, but again, that's not quite accurate. So this is actually a quarter of the moon that we're seeing. A half moon is actually a full moon because we're seeing half of the moon. We're seeing one side of it. We're not seeing all 360 degrees. So this is actually just a quarter moon. And that's what we would see here. Now, as it continues traveling, we get over about there, we can still see a lot of this moon. At this point, it is a gibbous moon. We're seeing a lot of light and a bit of it is shaded in. But we can see most of it. You know, I should probably write the word, right? Let's put gibbous. That's probably Latin or something. And there's a quarter. And a crescent. And there's the new moon. And now, once we're over here, and we're looking at this thing, we see a beautiful, bright, full moon. It's completely lit. And that's half our cycle. And this is taking like 14 days, roughly about 2 weeks, to go from new moon to full moon. Now it starts going away, which is sad. Oh, the other thing that's cool about this is once you're at the full moon, just like the new moon, instead of being in line with the sun, I mean, I guess it's still in line, but it's on opposite ends. So while if we're sitting right here, that's noon for us. Right here, when it's directly overhead, that's going to be midnight. And you can tell time the same way that you can with the sun. And you can even use the moon for direction, which is how I started learning about the phases of the moon. And hopefully this doesn't take me too long and I can explain that, how that works. All right, so now we continue our journey around. And this is where it starts to get a little bit complicated to me because the sides flip. So if I'm standing right here looking at this thing, and this is my right-hand side and my left-hand side, even though this is still facing that way, for me, what I see, that's why I wrote the left and right, if I'm looking at it that way, the left side is lit up. So it's gonna be that way. So if I'm standing there looking at it, does that make sense? The left side is the one with the light on it, and the right is in the dark. Oops, did I do that backwards? No, yeah, so there's the left. And so now we have another gibbous moon. But, and this I probably should have said earlier, this is a waning gibbous. Because waning meaning it's going away. The moon is getting smaller now. Whereas on the other side, it was waxing, which I guess means bigger, but whatever. Then we get over here, and again, if I'm looking at it, the left side is lit up, and we're seeing a quarter of it. And we've got a waning quarter moon. Let's abbreviate that some. And now, if I'm over here, it's in the dark. And we're just seeing a little sliver of light on the left side. And there's our waning crescent. So why is this useful to know? And how do I remember the difference between waxing and waning? Is I think of left. If the left side is lit, then the moon is leaving. So just all those L's. That's a little mnemonic device I use. Left side is lit, it's leaving. So it's a waning crescent or a waning quarter, waning gibbous. And if you know the cycles of the moon, you know where you are in the month. If you count, I mean, or at least you got a better idea of like how much time has passed and things like that. You can look up at the moon and know where you are basically in that cycle if you can recognize these different things. Now, here's something I learned is really cool. And I first read about this from Tristan Gooley. He's got several books about like natural navigating and whatnot. And I found this to be true with my experiments. If you, say you're looking at a crescent moon, and you make a line connecting those points like that, this points very close to south. Quarter moon, make a line like that, south. Gibbous moon, south. Full moon, you just treat it like the sun. Rises in the east, sets in the west. Figure out from there. Same thing happening here. You connect the tips of the moon, and it will very roughly, that was kind of hokey, point you to south. I've been experimenting with this at various phases, and it seems to be accurate. And I thought that was amazing. So nighttime navigation, if you can see the moon, you can get a ballpark idea of your direction and also your time and where you are in the month and just a ton of information like that. I am going to leave the tides to a different